Hello everybody, Mark E. Shaw back here for another Raspberry Pi synthesizer project. Today we're going to be taking a look at getting Sunvox to work in the Linux console without the need of Xorg or any type of desktop environment. Now the whole purpose behind doing something like this is so that basically we can just cut down on the amount of system resources that are being used. Obviously we're working on a Raspberry Pi Zero here, which is not the fastest of machines, so anything we can do to cut down on the amount of resources that we're using is certainly a good thing. And plus, I thought it was a pretty cool learning experience. To get started, all you're going to need is a fresh installation of Raspbian Lite that comes without a desktop environment whatsoever. Now, the first thing you're going to want to do after running Raspbian Lite for the first time, of course, is go ahead and run sudo raspi config, and there's just a variety of options in there. Go through that and make sure you connect to your Wi-Fi. One thing that was actually really helpful for me during this process and speeding up Sunvox was changing the screen resolution to something like 800 by 600. You can change that under your advanced options in Raspi config. Feel free to change it to whatever you prefer. And of course, one thing I like to do as well is change the localization options, make sure I specify my country's keyboard layout. Another part of this that's actually crucial for the speed and boot time of everything is that you want to change your boot options to console auto login. I want this thing to automatically log in and load Sunvox, and that's basically it. One thing that makes this process a lot easier is enabling SSH. I think that's a crucial part too. Let me just go ahead and add that in here, right here. Enable SSH in Raspi config. That's going to make your life a lot easier when you're maybe pasting in some of the information I'm about to show you actually. Of course, once you've enabled SSH, run the ifconfig command, and it's going to show you your IP address so that you can use something like PuTTY to log into the Pi. All right, let's go ahead and terminal into the Raspberry Pi, and we'll go ahead and get this thing set up. Okay, I have PuTTY opened, and we are SSHing into the Raspberry Pi. Of course, we'll log in as the default user. It's always generally good to run two very important commands. One is sudo apt-get update. This is basically going to look through the apt repositories that are already configured on your system and just check for updates in the packages and in the index. It is important to do that because a lot of times, you might run a command and maybe the location of a package is totally changed. So go ahead and run that update command. And once the update process is finished, another thing that's really good to run is the RPI-update program. I've shown this in a previous video as well. It's just something that's just essential, man. Just go ahead and run it. It's going to apply any kind of firmware updates that might be available for the Pi, so just go ahead and run it, and when it's done, make sure you reboot your machine. Okay, cool, so that's all finished up. Let's go ahead and reboot the Pi. And we'll be back shortly. Now we have a nice freshly updated system. Everything is the latest and greatest. So the first thing we need to install is a little library called libudev. Udev is basically just a kernel device manager for Linux, and libudev is the library in which programs can utilize that device manager. So we're going to go ahead and install that first. I know you can install more than one package at a time, but I thought it'd be a good opportunity for us to kind of talk about each one that I put on here just to make life a little easier and understand why the heck we're doing some of this stuff. Okay, now that libudev has finished installing, I'm going to go ahead and put links on here too, which, as some of you might know, is the best web browser on the planet. Go ahead and get that installed, because you're going to see here shortly I'm going to use links to download a couple things from the web. We're going to download the source code for libstl, and of course we're going to download Sunvox itself. www.libstl.org. Now here you can download whichever one you want, the regular zip file or the tar and gzipped file, and it's going to download really quick. It's very small, so not a big deal. To exit out of links, we'll hit Control-C. Let's go ahead and gunzip it, and tar VFX, the name of that file. Now, of course, some of you might be saying, hey, Mark, you can just install libsdl through apt-get. Well, yes, you can, but the only problem is that's kind of like choosing the express installation on something in Windows. It's great that it's there, and 9 times out of 10, it's going to work perfectly fine. But if you're doing something crazy like I am, then download the source code because it's going to give you a lot more advanced options, and basically it lets you compile certain types of support into the software. Now, this might be familiar to some of you guys out there, but anytime you download some type of source code, it's going to come with this configure script that allows you to set a whole bunch of options for that program. By default, libsdl is something that's typically utilized in a desktop environment like Xorg. So essentially, we have to reconfigure this so that it says, no, we don't want you to have any support for Xorg. We want you to pretend that it doesn't even exist on this system. And I have a bunch of different attributes in the configure script here. You do have to put a / in there to make sure you're specifying that script. And then we have all these options here for specifying the host, what stuff we're going to be disabling, like OpenGL drivers, the X11, which is Xorg, the X11 video drivers, Pulse Audio, it's another type of audio system for Linux, ESD, and Video Wayland. Wayland, of course, is another type of desktop environment similar to Xorg. The configure script's basically just going to run through and check your system for any kind of dependencies that libsdl needs. Okay, now that the configure script is finished running, there's no errors, everything's good to go. We're going to run the make command now with a couple little attributes as well. We're going to use -J4. That's basically the amount of simultaneous jobs that the compiler will process at once. This particular process is the one that takes a long time, so be prepared. Go relax for a little bit. Let's go ahead and get it done. Cool, it's finished. So now that the compilation process is done, the last step you need to do when compiling any kind of source code is basically run the make install command. Now, for this process, we do need to issue sudo make install, because what that's going to do is take some of the files that we just compiled and copy them to parts of the hard disk that you might not have access to as a regular user. So you can compile the software just fine in your home directory, but when it comes time to make install, definitely issue sudo. You need to be elevated to do that. That part only takes a few seconds. Now, because we just installed essentially a new shared library, and we'll do sudo ldconfig. This essentially updates the shared library cache and linking in the system. So anytime you do that, it's definitely a good practice to go ahead and run that command. Just kind of refreshes everything. The next thing we need to do is start editing the dbus system. It stands for desktop bus. You know, you could have a whole video just explaining what this actually does, but essentially it's just a messaging system that allows applications to talk to one another. Dbus has a variety of permissions that you can set and policies. Sudo su as the elevated root user, and we'll go under the user share, and I believe it's dbus, yep, dbus-1 directory. And in here is the system.conf file. That's the configuration file. Now, some people might scoff at me for doing this because there are other configuration files that reside under the etc directory. It uses a systemd type configuration where there's multiple sub-config files. But, you know, I tried so many different ways doing this before, and it just didn't work. So I went to the source of the problem. We're going to edit the system.conf file directly. So in here, we just need to find a nice blank spot. I like to scroll down to where I start seeing policies being created, because we're essentially going to be making our own policy in here. Just keep an eye out for the end tags. You want to make sure that you put your new policy after one of these ending tags here. So let me go ahead and just make a little spot right here, and we're going to paste in this new policy. I'll have all this information written out for you guys as well, so you can just kind of copy and paste yourself. All right, so this policy is essentially saying, hey, we're going to give the Pi user access over the reservations of these audio devices. Now, I believe audio 0 is going to be the Pi's HDMI audio connector. And audio 1, it might very well be a USB device that you plug in your system. Same with audio 2. I just put them all in there because why not? You know, just in case I were to switch USB ports one day, maybe the system recognizes it as a different number. Either way, this should get you covered. So now we'll Control X and save that file. Now, another good practice in messing with audio stuff in Linux is to add your user to the audio group. Run this user mod command. Just for precautions, let's go ahead and give this thing a quick reboot since we've been making a lot of changes here. Never hesitate to reboot. Okay, we are back. Let me go ahead and log back in as the Pi user. And now let's go ahead and install Sunvox. Not a big deal. We're not going to necessarily run it or configure anything yet, but I just figure we might as well knock it out now. And again, we'll run links, and we'll go right to the Sunvox website, warmplace.ru. And in here, you'll see the download link, Sunvox for Windows, Mac, Linux, and Windows CE. I'll go ahead and grab that guy and save it. All right, so Control-C out of links. And there's our Sunvox zip file. I'm just going to go ahead and get that ready for us. So now that Sunvox is installed, there's two other things here on our list that we do need to get installed as well. One of them being Jack. Again, since this is Raspbian Lite, it does not come with anything like Jack or any kind of graphics or audio library, so you do have to install that. Sudo apt-get install Jack D2. We do want version 2 of Jack, not version 1. And as you can see, Jack has a crap load of dependencies here. All these different things listed on the screen need to be installed, which does kind of make me a little sad, but it is kind of one of those necessary evil things. You'll even notice that Jack does require some things from Xorg, including this X11 common package right here. Just keep in mind, it's not going to be a desktop environment. It is going to be straight up console use here. Now, there is a part of the configuration here when installing Jack that's going to ask you about real-time priorities. You know, in order for this to really work correctly, you do need real-time support in the kernel, but you know, it's not really necessary for what we're doing. I go ahead and enable this anyway, just in case one day I do decide to compile support in the kernel, and maybe I can utilize it a little bit more in the future, but it's not going to hurt anything by selecting yes here. So the next thing we need to do, the last thing we need to install here, is a little program called A2J MIDI-D. Now, this essentially creates a bridge between ALSA and Jack, and it allows you to take ALSA MIDI-based devices like my Akai MPK MIDI and just connect them in and bridge them over to Jack. It is an essential part, and this is one of those things that you just never saw before when using QJack-CTL and running Sunvox within Xorg and all that stuff. But believe it or not, it's something that you need to install manually in this type of environment. So let's go ahead and get that rolling. The next thing we'll do is go ahead and edit our Jack DRC file. These are going to be the Jack server options that run as soon as Sunvox starts. So if we go ahead and do a Pico, or we'll go ahead and do Nano, just in case somebody gets mad at me. All right, Jack DRC is the file. And this is basically like an auto execution program. You know, you can specify your Jack parameters in here. The ones I have are these right here. Of course, the first thing is the path to Jack itself, which is user/bin. Then Jack D is the binary. -P70 is a real-time priority. It's probably not even necessary for this, but I went ahead and put it on there anyway. There's just a couple other things, but really the most important thing here is the -DHW:2, 0. That's the device location of your audio interface. I'm using the same Sobrent USB audio device that I've showed off before. You know, the real cheap one with just a microphone input and a speaker output. Nothing special there. I'll show you how we can locate those numbers here in just a second. This is, of course, is our frames. 256 is what we're shooting for. And our rate, our hertz rate, is going to be 44,100. Seems to work the best for the Pi Zero. You do need this little ampersand at the end of it too, because that's going to allow Jack D to run in the background. So we'll hit Control X and we'll save that file. Hit yes, enter. We're good to go. Now that Jack D RC file doesn't exist by default, so go ahead and create it if it's not there already. If we do a ls-la, we can list everything that's in there, including those hidden files, and Jack D RC is in there now. So cool, we're good to go. Run the a record command. It's just an also utility to literally record, but you can specify -L to list any type of input devices or interfaces that are on the computer. So if we do that, you can see here that we have a couple things. Card 2, that's the first number. You know, your computer might say card 1 or card 3, but in my case it's card 2, and then device 0. USB audio right here. So that's where 2, 0 comes from. But if we look at that Jack file one more time, Jack D RC, again in this case it needs to start with -DHW colon, then those two numbers, 2, 0, that should get you going. Alright, so the next step here is to edit our bash profile. Every time you log into Linux, it's usually running some type of shell, and in this case bash is our shell. The bash profile is something that runs every time you log in. Do nano, we're going to create this file, which is .bash_profile, and I'll paste in this, which is basically setting an environment variable for this particular variable right here, dbus session bus address. We just need to specify the path for where dbus, the system bus socket is. So that's just something that is required, or else you're going to get some dbus errors when you try to run Sunvox. Control X will save that. We're good to go. So now, at this point in time, in order to reload the bash profile, just simply log off and log back on the machine and you're ready to roll. So what I'm going to do now is take the camera off of my SSH session. We're going to go ahead and look at the Pi itself directly and try running Sunvox and start configuring all those settings as well. Alright, here we are at the console on the Pi. We're going to check out the Sunvox directory here and run the Sunvox binary. Make sure you go to the Raspberry Pi directory there. You can see that the mouse works great here in the Linux console without the use of Xorg. Thank you libsdl for that functionality. The first thing we're going to do is set up our audio options. We do need to go under audio and just set the driver to jack. And you'll notice that jack is not going to be listed under the MIDI tab yet. That's just because it doesn't detect jack instance running at the moment. So we do need to restart Sunvox first for this to take in effect. Now you can see it's showing up just fine. Select jack and close it out. Let's go ahead and adjust our interface just a little bit. I really think this 800 by 600 resolution works great for this particular application. Maybe not if you're using the pattern editor and some of the other fancy stuff that Sunvox does, but for what I like to do, which is just kind of fiddling around, this works perfectly. Okay, now I'm back over here at my desktop and I am SSH'd back into the Pi now. And the reason for me doing this is that I need Sunvox to be running behind me at the same time while I execute the next following set of commands. First, I wanted to show you guys a little something. It's a really neat command here called jack lsp. Now this commandlet is going to show you all the inputs and outputs that Jack currently has available. the next command that we would need to run in order to connect devices is jack connect. And if you run that, it tells you how to do it. Like for example, you could connect in System Capture 1 and connect it over to Sunvox Keyboard 1. But this isn't going to work. That's why we need that A to J MIDI bridge like I was talking about before. A to J MIDI D dash E with an ampersand at the end of it. Of course, the ampersand is going to allow the bridge to just kind of run in the background. It actually created yet another port. All right, so let me just press enter and you'll see that we're back at a prompt again. Now, here's the fun part. This is actually a little tricky and took me forever to figure out because syntax means everything in Linux, especially when it comes to this kind of stuff. When I look at that jack connect command and I see it says port 1 and port 2, what the heck does that mean? Is it just talking about this number right here? Is it talking about like the name? It's literally talking about this entire line right here. So take this whole line and copy it. Put it in a notepad file. And now I'm going to go ahead and paste in what the jack connect syntax is going to look like. Now pay close attention to this because these single quotes are probably the single most important thing about this command in order for it to work correctly. I had to kind of do some trickery to get it to work, but essentially the first part, the MPK mini, all the way up until the point where it says capture in parenthesis, those I put in single quotes. And then there's that colon, of course. We do have to keep in that empty white space right there. There's a blank space in between that next single quote and then the letters MPK. So believe it or not, that line has to be in single quotes too. That's port number 1. This entire line right here is port 1. Port 2 is Sunvox itself. You might remember this from me showing you QJack CTL. You're connecting the device to Sunvox Keyboard 1. The minute you do that, your device is now available to be used in Sunvox almost immediately. We're going to make a nice script that does all this for you, because essentially you would need to run this every single time you start up Sunvox. But that's a real pain and it's totally inconvenient. We can go ahead and flip back around real quick and start hearing how this thing sounds. Alright guys, so as you can see, that works pretty well. The last things we need to do here is just make a little script to make our lives a heck of a lot easier. I just called it Sunvox Start. And in this script, I've made it as easy as possible. Of course, we have our shell declaration up at the top. And then the first thing here is the direct path to the Sunvox binary. And of course, at the end, we put an ampersand there. That's going to allow Sunvox to kind of run in the background per se and allow other commands to be executed simultaneously. So the moment that runs, it's going to sleep for 5 seconds. Just allow Sunvox to fully load before running this bridge. And after that, we're going to do sleep 1 before running the jack connect command. Now the last line was a little experimental. I was hoping that when Sunvox was closed that it would kill the bridge. But unfortunately, it just won't work. But if anybody can figure that out, feel free to leave a comment below and we can go ahead and make that adjustment. Maybe one day we can make this thing its own little Linux distribution, like the Sunvox OS or something like that. So I'm going to go ahead and exit out of that. Now the last thing we need to do is edit our bash profile one more time. Of course, we still have our export dbus up at the top, but then right underneath is // the name of the startup script for Sunvox. So let's go ahead and pray real quick. We're going to turn around and try to turn on this Pi. I'm going to go ahead and reboot it from scratch. We'll film it and see if this thing loads up Sunvox and everything works. One more quick important note is that you need to take your startup script and mark it as executable using chmod +x than the name of your script. Otherwise, you'll just get a permission denied error. Alright, let's go ahead and reboot the Pi. All right, guys, well, that wraps it up for today. I hope this has been informative. I know it was hours and hours of frustration, so I really do hope that it's able to help some people out that are interested in this kind of thing. I appreciate you guys watching. Check out the video description for links to all the products that I've used. They are affiliate links, and it really helps me out. If you like this video, subscribe to the channel, share with your friends. I'm trying to take on a lot of new projects this fall and winter. The cool thing is now this is my full-time job, not necessarily YouTube, but just creating in general. I've worked in the technology industry for 20 years, and now I'm off on my own, doing my own thing, and just happy to be here, a part of all the action. I would love to hear from you. Comment below. If you have any questions, comments, let me know. I'd be happy to help. Thanks again, guys. Hope you have a wonderful day, and take care.
Time coming, what a sight to see.